You're welcome to today's class. And in this class, we'll be looking at this problem under energy balance. Before we proceed, I will encourage you to like the video, subscribe to the channel, comments, and share with your friends. Okay, quickly let's look at the problem before us. The question says, an autoclave contains 1,000 cans of what? Of pea soup. Now you can see from this diagram here, this is the diagram for autoclave. This is an autoclave diagram. You can see that inside this autoclave, we have pea soup here. And this pea soup, they are inside what? They are inside can. Now the question before us says that we have 1,000 cans. That is, if we have 1,000 cans and each cans contain what? Pea soup. Therefore, we have what? 1,000 pea soup as well. The same way we have 1,000 cans, the same way we have 1,000 pea soup. Okay, now from the question, we're told that it is heated to an overall temperature of what? Of 100 degrees Celsius. That is, the can and the pea soup were both heated to, okay, then the specific heat capacity of the pea soup, take note, the specific heat capacity of the pea soup and the can, the metal cans, they are what? And they are 4.1 kilojoule per kilogram degrees Celsius, and the second one is 0.50 kilojoule per kilogram per degree Celsius, respectively. Now, if you look at this specific heat capacity that was given here, we have two here. This is the first one, and then this is the second one here. Okay, so you can see that the pea soup here came first, right? Followed by the can. So the first specific heat capacity here is for the pea soup, and the second one here is for the what? Is for the can. Okay, the weight of each can is 60 grams. That is, each of this can that is present here has a weight of 60 grams. Of course, we know that we need to convert the weight, that is the mass. We need to convert it to kilogram. Why? Because if you look at all other parameters that were given, they're usually in kilogram. You can see here is kilogram. You can see that here we have kilogram. You can see that we have kilogram here and some others. So we need to convert the mass here to be in kilogram. Okay. We also told that the cans contains what? Contains 0.45 kilogram of pea soup. That is, each can, each can has its own weight to be 60 grams. Of course, we need to convert it to kilogram, and each can contains, we're told that it contains 0.45 kilogram of pea soup. Okay, assume the heat content of the autoclave wall. The heat content of the autoclave wall is at what? At 40 degrees Celsius. That is, the autoclave wall, the inside here, the inside of this autoclave here, the wall inside, the heat content is 1.6 times 10 raised to power of 4 kilojoule. Okay, and there is no heat loss to the wall. Take the specific heat capacity of water to be this, that is 4.21 kilojoule per kilogram per degree Celsius. That is specific heat capacity of water. Then if the can are to be cooled to what? To 40 degrees Celsius, then take note that we're told at the beginning that the cans and the pea soup were both heated to 100 degrees Celsius. Now we are not dealing with the cool aspect. Now we want to cool the can to reduce the temperature from 100 degrees Celsius to what? To 40 degrees Celsius. Now we want to cool this can. And what are we using? We are using what? Water, because we're told to calculate how much water that will be required to enter. So we need to pass through water here. Water will have to enter this autoclave here, and as water enters here, the can will begin to cool, and the pea soup will begin to cool, and the heat content around the heat content of the autoclave wall will be cooled as well. So water here will be doing three major works here. The first thing is water will begin to cool the autoclave wall here. It will cool the autoclave wall. Water will begin to cool the cans, and it will also cool the what? The pea soup. That is, water will absorb the heat from the autoclave wall. It will absorb the heat from the cans, and it will also absorb the heat from the pea soup. We want to reduce the heat to 40 degrees Celsius, and it is water that will reduce the heat, that we have to absorb the heat. I know as water is absorbing the heat, water himself will be increased. The temperature of the water will increase. So that is why we're told that we're asked to calculate how much water that will enter at 15 degrees Celsius. That is, this water we are passing through, it will enter at 15 degrees Celsius and leave at 35 degrees Celsius. That is, if the water enters at 15 degrees Celsius and water begins to absorb heat from the can, from the pea soup, and from the autoclave wall, the temperature of the water will begin to increase. So we want to calculate the mass, that is the amount of water that will enter. Okay, quickly let's begin to analyze our parameters given in the question. Okay, let's analyze the parameters given in the question. Now we're given the numbers of cans to be 1000, just as I've explained earlier, and as you can see, we're given the initial temperature. That is, the first temperature that was given there was what? 100 degrees Celsius. Okay, then we're given the mass. We're given the mass of the can to be 60 grams. Of course, I told us earlier that we have to convert the 60 grams to kilogram. Okay, now to convert 60 grams to kilogram, we divide by 1000. So we can see that it gives us 0.06 kilogram. Then we're given that the mass of each pea soup, we're given it to be what? Is 0.45 kilogram. The mass of each pea soup, we're given it to what? To be 0.45 kilogram. Mind you, don't forget that we have 1000 pea soup there. That is, we need to multiply by 1000. And don't forget that we have 1000 cans as well. So the mass given here is for just single can. Okay, take note of that. Then we're given the specific heat, that is specific heat capacity of the pea soup to be what? 4.1 kilojoule per kilogram per degree Celsius. And we're given the specific heat capacity of the can as well to be this 0.5 kilojoule per kilogram per degree Celsius. Okay, and we're given the heat content of the autoclave wall to be this 1.6 times 10 raised to power of 10 kilojoule. Now don't forget, I said water will be doing three things. When water enters the autoclave, it will absorb the heat content from the autoclave wall, just as you can see from the question here. It will absorb that. Then it will absorb the heat from the, and the heat from the autoclave wall has been stated, so we don't need to calculate it. It has been stated here. Then we need to calculate the heat that water will absorb from the can, and the heat that water will absorb from the pea soup. So water will absorb heat from the three of them. Okay, now so let's proceed. We're told that the specific heat capacity of water is given to be 4.21 kilojoule per kilogram per degree Celsius, and we're given that the water enters at 15 degrees and leaves at 35 degrees. Yes, if water enters and water begins to absorb those heat, the temperature of the water will have to increase. Let's proceed. Then we need to calculate heat removed from the pea soup. Yes, as I've said, we need to know the heat that water removed from the pea soup, the heat that water removed from the cans, and we need to know, we have already know the heat that water we have to remove from the autoclave wall. It has been given, so we don't need to calculate for autoclave wall. So we need to calculate for the pea soup and then for the can. Okay, so and to calculate that, we make use of this formula, all true. That is, our Q is equals to mass times specific Q, which stands for heat, is equals to mass times specific heat capacity times change in temperature. Okay, now we want to calculate for pea soup now. Now we already know the mass of pea soup. We already know the mass of pea soup. The mass of pea soup is given to be what? Is given 0.45 kilogram. But let's take note of something. Is it 0.45 kilogram, right? But we have 1000 pea soup. This 0.45 kilogram is for just single, it's for just a soup within just a can. And we are considering 1000. So we have to multiply by 1000 to know the total mass of the pea soup. So the total, to calculate the total mass of the pea soup, we multiply 0.45 times 1000 to get what? That is 450 kilogram. So that is the mass of the pea soup. Then change the temperature. We're told that both the pea soup and the can were both heated to a temperature of 100 degrees Celsius. Then at the final, we try to reduce the temperature to what? To 40 degrees Celsius. So what is the change in temperature there? 100 minus 40. That will give us what? 60. So the change in temperature is given to be 60. And then the last one there that we are left with is the specific heat capacity. And the specific heat capacity of the pea soup has been stated from the question. You can see it here to be 4.1 kilojoule per kilogram per degree Celsius. Now, since we already know the mass, we already know the specific heat capacity, and we already know the change in temperature, then we need to substitute these parameters into the formula. That is heat, Q, is equals to mass times specific heat capacity times change in temperature. And that gives us what? 110,700 kilojoules. That is this for the pea soup alone. Now, this is the heat that water we absorb from the pea soup. And now we already know the heat that water we absorb from the autoclave wall from the question here. So the next one we have to calculate. The next one is to know the heat that water we absorb from the can. Okay. So to calculate the heat that water we absorb from the can, the heat that water we absorb from the can. So as I've said, we still make use of the same formula. That is, our heat Q is equals to what? Is equals to mass times specific heat capacity times change in temperature. We already know that our mass has been given from the question. The mass of the can, as I've said, that it was given as 60 gram, and then we converted it to kilogram, and that gave us 0.06 kilogram. And you know that we're told that we have 1000 cans, so we multiply by 1000 to know the total mass, and the total mass is what? 60 kilogram. Then, as I've said, that we'll be using the same formula all through. That is Q, which is heat, equals to mass times specific heat capacity times change in temperature. So we already know the mass. So what about the specific heat capacity? It has been stated in the question that the specific heat capacity is given to be 0.50 kilojoule per kilogram per degree Celsius, just as you can see here from the question. Then we already know the specific heat capacity. What about the change in temperature? We have calculated it earlier. The change in temperature, because this temperature is for both the can and then the pea soup. They were both heated to 100 degrees Celsius. That is, pea soup was heated to 100 degrees Celsius, and the cans were also heated to 100 degrees Celsius. So both of them are to be cooled to 40 degrees Celsius. So we have calculated the change in temperature, and then the change in temperature gives us 60. So if you substitute that into the formula, that is Q, which is heat loss from the can meter, is equals to what? Mass times specific heat capacity, the mass times specific heat capacity times the change in temperature, just as you can see here. So by the time we calculate that, we arrive at 1800 kilojoule. Now, we have calculated the heat loss from the can meter, and we have calculated the heat loss from the pea soup. That was the first calculation we performed, and we already know from the question that the autoclave wall has a heat of what? 1.6 times 10 raised to the power 4 kilojoule. So we already know the three of them, because water we absorb the three heats together. The total heat from the three is the total heat that water we absorbed. The total heat that water we absorb from the autoclave wall is 1.6 times 10 raised to the power 4 kilojoule. So the total heat that water will absorb from this can is what? 1800 kilojoule. And the total heat that water will absorb from the pea soup, we have calculated it earlier. So we need to add the total heat together that water we have to absorb. So yeah, before we go to that, the autoclave wall, the heat has been stated from the question, that is 1.6 times 10 raised to the power of 4 kilojoule, which is also the same thing as 16,000 kilojoule. Yeah, that one has been stated. So now the total heat that water we have to absorb is what? The water we have to absorb from there. You can see it here for pea soup, the heat loss from the pea soup plus the heat loss from the can meter and the heat loss from the autoclave wall. So you can see the three of them were added together here, and then we arrive at 128,500 kilojoule. So 128,500 kilojoule is the heat that water we absorbed. Is the total heat that water we absorb from the three of them. That is the pea soup. From the pea soup, water we absorb 110,700. From the can, water we absorb 1,800, and the autoclave wall, that is the can wall, not this is autoclave wall, not can wall, is the autoclave wall. So water we absorb 16,000 kilojoule, that is 1 point, it's still the same thing as 1.6 times 10 raised to the power 4 kilojoule. So the total heat is 128,500. Then since we already know that, then we need to calculate, the function of the water there is to cool the three of them, the can, the soup, and the autoclave wall. Then as water is cooling them, what is happening to water? Water itself is also observing. As water is cooling them, water himself is also doing what? Absorbing the heat. So to calculate that, we have heat absorbed by the water is equals to the mass of the water. As I've said, don't forget, I said we still be making use of this formula. We make use of this formula all through. Heat, that is Q, is equals to mass times specific heat capacity times change in temperature. So we already know the heat that water will absorb to be 128,500. Then the mass of the water is what we are calculating in this video. It's what we are calculating for. So the specific heat capacity of the water has been stated from the question, 4.1 kilojoule per kilogram per degree Celsius. And the change in temperature, don't forget that we're told that water will enter from the question here, it will enter at 15 degrees Celsius, that is our T1, and it will leave at 35 degrees Celsius, that is our T2. So what is the change in temperature? The change in temperature will be what? 35, that is our T2 minus the T1, which is 15, that will be what? 20. That is our change in temperature. So we already know the change in temperature, we already know the specific heat capacity of the water, and then we already know the total heat that water will absorb. So we need to calculate the mass. This is what we are calculating for. And to calculate the mass, I will make mass subject to the formula. And to do that, I will divide both sides by the coefficient. That is, I will divide both sides by specific heat of water, specific heat capacity of water, and the change in temperature. So if I divide that, I will have times change in temperature. So if you do that, if you make mass subject to the formula, this is what we have. So we have this, if you multiply this heat with this one, it will still give you Q. 1 times Q will give you Q. That is, that Q stands for the heat absorbed by the water, and then this is the specific heat capacity of the water, and then this is change in temperature. So if you should do that, if you substitute the parameter inside, this is what you have. And then if you complete the calculation, so this is our final answer, approximately 1,526 kilogram of water. So this is the mass of water that we have to enter the autoclave wall, that we absorbed this amount of heat, that is 128,500. This mass of water will enter at 15 degrees Celsius, and to absorb this amount of heat at 35 degrees Celsius. All right, so we have come to the end of this video. Please consider to like the video, subscribe, comment, and share with your friends. Thank you. See you in my next video.